this section 5.2, we're going to talk about count vectorizer TFIDF. So we talk about, how do we convert, how do we assign some sort of values to words, right? So now we have all these words tokenized in this format, right? One word is a token, right? But we have to assign some sort of values, right? Some sort of like numerical values to it, right? So let's talk about count vectorizer, word vectorization. So count vectorization is called vec of word. So meaning like you want to count the frequency, right? The frequency of the words appear in your document, in your sentence. Remember, so this is our vocabulary, right? We have, a unique set of words, right, in our vocabulary. And then remember the first list, right? So we got to the list of lists, right? After going through all these steps up to lemmatization, we got a list of lists, right? So now we can actually convert this list into numerical lists as opposed to a list with tokens, right? So you can see Jeff in our vocabulary is actually is third one, right? So that means the way that we convert this is whenever we see Jeff, we want to add one value to the third position, right? So as you can see that if you have huge vocabulary, right, like lots of words in your vocabulary set, then you're gonna have a huge vector, right? You're gonna have maybe 1,000, a vector with 1,000 or 2,000 elements. But in this case, we only have 10, right? 10 words in our vocabulary. So we can actually say Jeff. Whenever we see Jeff, it's going to be third, right? The third position will have one addition, right? We can actually do counting of the frequency, right, of the words. So still is actually the last one. So therefore you can see that we're adding one to this, right? And octopus is actually the fourth one. We're adding it in here, right? So and then sandwich is actually, I'm going to use that. It's this one, right? So this is like the concept of vec of words. You can actually see if a word appear twice, like sandwich, then you have two, right? So it's a very simple bag of words. Think of you have a bag, you're just adding words to or tokens to your bags and then do the counts of that. So this is very straightforward. This is how you can numeratize your vector of tokens, right, from here to here, right? So that's one way of vectorizing things. And the other way is it's called TFIDF. So TFIDF has two terms, right, two components. The first one is called term frequency, so that's TF, right? And then IDF is inverse frequency, right? IDF is inverse document frequency IDF, right? So TF, the definition is pretty straightforward, right? It's the number of times word appears in a document over total number of words in a document, right? It's just a frequency, right? So you can actually see TF, you can actually get something like this, right? So Jeff appears once in this document, but it appears 4 times in the entire corpus, right? So it appears in every, right? So therefore you can actually see it's 1/4, right? So, okay, great. So then, yeah, and then document frequency is the number of documents containing word over total number of documents, right? We can actually do the same thing. Obviously, these words all appear, right, like once, right? So number of document containing the word over total number of documents. So you have 3 documents, right? And then number of document containing drop is actually 1. And then number of document containing help is 1, and so forth. So inverse document frequency is actually combining the two, right? So the total number of documents over total number of documents containing the word and taking a log of it, right? So, and then after that, TF-IDF is pretty much TF times. You're taking a dot product of TF and IDF to get to this number. So after this vectorization, we can actually see the first list, right, that's coming from the first document will be converted to this vector, right? 0, 0, 0.275. So compared to what we had for from count vectorizer, right? Notice that this number is actually a lot smaller, right, than the one that we had, right, from count vectorizer. So I mean, this is to really see. I guess the intuition here is really that when you see a word that contains a lot of meanings, right, then you want to definitely assign like a very unique word that you'll see, for instance, like homogeneous, right? That doesn't appear too often, but it has a lot of meaning to it. So you want to assign more higher weights, right, to that word than, for instance, U, right? A word U or a word cup, right? So that's the difference between count vectorizer and TF-IDF. So count vectorizer is a bag of words, pure counting of the frequency of the words. However, TF-IDF is to add this another term that's called IDF, right? So inverse document frequency, right? Times term frequency. That's pretty much it. So now we have this vector for this document, right? For the first document, we'll have this vector. So let's look at something, right? So cosine similarity is actually a good way of looking at the distance or the angle between two vectors, right? So I imported initially from a scalar. So this is a imported function from a scalar. I can actually pass two vectors like this, right? So here I'm actually passing the first vector that I got from TF-IDF for the first document, and the second vector I got from the second document, right? You can actually then take the cosine similarity. You can actually see 1, 1, right? Because this is to itself. This is to say that first the distance or the angle or how similar, right? The first document to itself. Then of course it's going to be 1, and this is going to be 1 as well. But this and this, they're symmetric, right? But this is to say the cosine similarity between the first and second documents, right? The first vector and second vector is 0.08. I mean, I wouldn't think that is very high in terms of cosine, how similar they are, right? In terms of cosine similarity, but we can try something else, right? Like let's say we want to do something like second and third, right? Like look at the cosine similarity of second. So this is our second. Already, let's look at the third one, right? So third one is not, that's already the third one. So like this one is the, right, this one is the second one. Okay, so if we look at this, right, so cosine similarity, yeah, remember that you have to pass in a format that's a list of this. So really the cosine similarity between the second and third, right, these two are 0. It shows up as 0, right? It can happen. It just means that they're not similar at all, right? So, okay, let's, in our next section, we're going to talk about example using our spam data, but this is it for section 5.2.